going to be the last section from chapter 5. And it's called the substitution rule, at least that's the name of it, and it's section 5.5. And it's probably one of the most important sections in this course. So we're going to be spending most of, well, all of today and most of tomorrow doing it. So what is this fella called the substitution rule? Well, basically it's a technique that allows us to find antiderivatives of really complicated, sometimes very complicated integrals that you couldn't do any other way. So if I asked you to find the antiderivative of that, I don't think we'd have an issue. Would you agree? It's a power rule. And you would add 1 to the power. And basically you'd get that. And if you were being asked to find the integral from 0 to 1 of this guy, you would still find this fella. You wouldn't write the plus c, but you would evaluate it at 0 and at 1, and you can just trust me, you'd get a quarter. Well, the reason that we can find antiderivatives of x cubes is, well, because we have a lovely big table of things we know the antiderivative of, and that's about it. But what happens when you get a question and they give you an integral that is not in this table, and you can't do some algebra to make it in this table? Because some of the questions we got earlier, weren't we? We just figured a way to FOIL it out or factor it or do something to it, so it ended up being one of these guys. But what do you do when there's an integral where no matter how you make it happen, it's just not going to turn into anything like that? So I'll give you an example of what that might look like. These are the kind of questions where the substitution rule was kind of designed for. Do you know there's no algebra, factoring, trig identity, not that you could even think of a trig identity in this situation, in the world that is going to get this guy to look like any of these guys, right? Would you agree? It ain't happening, right? Can't do it. So I guess the first attitude when this question was first posed would be, well, you can't do it, stop bugging me, let's go back to the ones we can do. And then some mathematician said, no, I don't like that answer. I want to know what the antiderivative of this is. I'm not just going to give up, I'm going to figure a way of making it happen. So this is the process that we're going to use. This is the substitution rule process. The first step 1, is we're going to choose a suitable U substitution, because essentially what's going to happen here is you're going to take a problem that you can't get the answer to. You're going to change it into a question that you do know the answer to. You're going to get that answer, and then you're going to use that answer to figure out what the answer to the original real question was. So it's a kind of sneaky trick of change the question into another format using substitution. So step 1 is choose a good substitution. And I'm going to use that substitution. I'm not going to tell you why I picked that one rather than any other, but you could have a guess that isn't at the bottom of the fraction, so that's probably why I chose it, right? Now, that is called a U substitution, right? Or U sub for short. That means U is going to be the same thing as this guy. Now, step 2 says, convert all of the terms, that's all of these, into U. Well, you can see there are a couple of terms that aren't going to work. Would you agree 4x squared isn't going to be able to be turned into a U, and dx isn't going to be turned into anything with a U? And that's why There is a process for making that happen. And there's a little bit of magic going on here, and it's really cool. What you do in step 2 is you take your u substitution and you differentiate u with respect to x. So you are now going to be doing a lot of calc 1 in these questions. In other words, you're going to be doing a lot of differentiation. So if you thought differentiation wasn't going to be a big thing, because we're doing lots of antiderivatives, that's not the case. We're actually going to be differentiating a lot more than you think. Now, if you differentiate this, hopefully we can remember how that works. Would you agree you get 6x squared? Now, the next couple of lines are going to be magic, but you have to just stick to them. You might have wondered why this notation is used for derivatives, why we didn't use, just like f-x kind of notation all the time. Why this is useful as a notation is that we are now allowed to do this. Isn't it a bit like it's a fraction? It's not a fraction, but it kind of behaves in some ways like it was a fraction. Can you see how this is the same as that? Can you see a little cross multiply thing? This becomes this. Now, why am I doing all of this? Well, my goal is to figure out how to change dx into something on its own, just to isolate the dx. That's all I'm going to do right now in step 2. Well, if I want to find out what dx is, would you agree it's 1 over 6x squared du? So you take your u sub, you differentiate it with respect to x, you do a little, I call this the crossover, you do a little crossover, and then you divide, right? Now you say, well, how's this going to work? Watch. I'm going to change to green here. You see this guy here? This fella? 2x cubed plus 1 is u. 4x squared right now is 4x squared. But can't I turn this dx into this guy? See the dx? I'm turning it into this guy, which means I'm going to turn it into 1 over 6x squared du. So we're still in step 2 here. I guess I need a little wall here. Can you see any simplification that I can do here? Can you see anything that I might be able to cancel, for instance?
Cancel out the x's.
Can I also maybe, while I'm at it, take care of the 4 and 6 and cancel them a little bit down as well? So when I do that, what I'm going to be left with is 2 over u du. And that's the essential magic of the substitution rule. What it is saying to us is, do you see this integral here with all the x's and dx's in it? With this substitution, it's the same thing as this integral over here, but do you see this integral only has u's in it? So you start with x's, and now you end up with u's. But what's good about this guy? Hey, isn't this guy a fella we know the answer for? Can't we get the antiderivative of 2 over u?
What happened to the 3?
The 3? Where is the 3? This 3?
No, I mean, when you canceled the x's.
Oh! That's what happened to it. It's still there. In fact, I'm going to rewrite this thing, kind of overemphasize it. Isn't it 2/3 of 1 over u? Right, now, let's do the antiderivative of 1 over u. What's the antiderivative of 1 over u?
Natural log of u.
Okay, so it's going to be 2/3 the natural log of u plus a c. And that is step 2 finished. Actually, that's step 3 finished here. So step 2 was to get to here. And step 3 was a really quick step. Get to here. So Step 4, the final stage. Convert your answer, which is this guy, back to being in terms of x. Well, 2/3 natural log of u becomes 2/3 the natural log of 2x cubed plus 1 add c. We now know the antiderivative of this guy. Is this fella. Sneaky, but kind of cool. WebAssign may ask you to do an absolute value around it. Can you remember when we did the log u thing? I said, look, technically it's the natural log of the absolute value of u, but sometimes you need it and sometimes you don't, and it's a bit of a pain in the butt to remember when, and so I typically just don't bother too much. And WebAssign sometimes does and sometimes doesn't. So just a little thing. If you're doing this question, you might want to stick an absolute value around the natural log to keep WebAssign happy. We cool? Right. Now, I am now going to do a kind of skill building exercise with you. We're going to look at how you decide who your U sub is. Not going to finish the question, not even going to attempt to finish the question. I'm only going to show you how to do the first step. How to recognize what the U sub should be in different situations. So here's some examples of this. If you ever see an integral where there's a bracket with some stuff in it and it's squared or it's cubed or it's fourth, like we have here, choose as your U sub the guy inside the bracket.
Professor, I have a question.
Yes.
So when you say, so we don't, okay, never mind. I answered.
Oh,
okay.
you've just answered
Yeah.
your own question. When you get a U sub that is the form of a fraction, like say something like this, choose as your U sub, at least as a candidate, the guy in the bottom. If you get a trig function, a sine, a cosine, a tan, or whatever it might be, and you see it's not sine of x or cosine of x, but sine of x squared plus 1 or cos squared of x plus 1, choose as your U sub the thing that's inside the cosine. Suppose you have to find the antiderivative of this ugly guy. What do you think might be a good, at least candidate for the U sub?
The exponent over e.
And that's a general kind of situation. Suppose you get a question and there is a square root involved, like this question. What do you think, I'll make that a 4 because it's a funny looking one. What do you think a U sub candidate should be in these situations?
What's ever in the square root?
Yep. Can you see that there's a kind of logic to many situations about who the u sub should be? Things inside square roots, weird powers, things inside cosines, bottoms of fractions, things inside brackets. Do you see that there's a kind of overarching theme of where you should go looking for your u sub, right? Now, I'm not going to do that would take us a long time, but every single one of these would work with the u sub that we've got. And for today, we're going to look at straightforward u subs, which are the ones you think you should use are in fact the ones that you should use. But one of the cool things, I think it's cool, is that when you get to some of the more complicated ones, which is probably going to be happening tomorrow, there are some exceptions to every rule. In other words, 90% of the time, this is a u sub. But here's a little special case where it's not the u sub, right? So this is slightly out of sync, but to give you an idea of what I'm talking about, in this question here, who would you use as your u sub?
The denominator.
Correct. What about in this question here?
You still do the denominator.
No,
No?
this is the special case, the 1 in every 100 or the 1 in every 10. In this case here, do you know that your u sub is actually log x? So that breaks the major rule. That doesn't make the major rule wrong. The major rule will work, as I said, 9 times out of 10, 99 times out of 100. You just got to, sometimes you will try the obvious u sub and it'll work and you'll be happy. And now and again, just now and again, you're going to do a u sub that doesn't work, right? It doesn't get you an answer. You can't get rid of all the x's, whatever it is. In which case you have to look at an alternate. If you want to know why does this work, well, when you differentiate it, this question ends up just being, if you use that as your u sub, this fella actually just ends up being that. It turns into the integral of u du. But maybe I shouldn't have talked about that one yet, because I was going to wait until tomorrow. So we are back to u subs, as in the obvious u subs are the right ones and they are going to work, right? And tomorrow we'll see some of the exceptions to the rule. So I'm going to start off with a relatively straightforward one. Now, before today happened, if I asked you to integrate that or find its antiderivative, isn't the only strategy you've got totally impractical? And that would be to FOIL that horrible thing out. To get a polynomial like 4 pages worth of writing, because it would be huge, wouldn't it? And then integrate, you know, antiderivative or integrate every single one of them. Oh God, it'd take you all day. But not anymore. This is step 1. What is the u sub for this situation?
2x.
2x.
Right, so aren't we working on the rule, if it's inside a bracket, it's probably going to be your u sub, right? And we're doing questions where the obvious u sub actually works, right? So we're not trying to catch you out yet. Now, you then differentiate this with respect to x. You do the crossover. And then you divide both sides by 2, because what you want to get is that line there. You want to find out what dx is. You can then go to this integral, and let's see what happens. 2x plus 1 to the 100, doesn't that just turn into u to the power of 100? Right, 2x plus 1 to 100 is u to the 100. What will the dx turn into? That's why I had to do this. Well, the dx doesn't turn into anything really that bad. Would you agree it just turns into a half du? I think the half looks better at the front. Right. Right, can I integrate that guy? Sure can. Isn't that guy just a classic power rule with a big number? So I will add 1 to the power. I will divide by that new power, which is where that weird fraction comes from, and I'll add c. So that's step 3. So there's step 2 here, and there's step 3 here. Now return back to x's. Well, it's 1 202, 2x plus 1 to the power 101, add c. Now, look at how much work it took me to do that, and that's me doing a lot of talking at the same time. Compare that against how you had to do it if I gave it to you yesterday. I said, look, you're not going to pass the class, I force you in some horrible way to make that happen. Would you agree it'd take you hours at least, probably, to do it? Look at that answer. Wasn't it like 3 minutes? And as an added bonus, isn't the answer nice and tight? It's not a big, horrible thing this size. It's a tiny little thing. I think that's kind of cool. How about this fella? Right, I need a u sub. What's the u sub in this question?
7x squared plus x.
Now I'm going to differentiate my u sub with respect to x. I'll do the crossover. And then I shall isolate the dx. Move this up a little bit. Are we comfortable with what I just did there? A little bit quick, but does it seem kind of has a flow to it that we follow a lot? So let's see what that becomes. This guy in the bottom becomes u. For a little while, I'll leave that guy alone, and I will replace the dx with this guy. And do you notice that these two things cancel out really nicely? And we now have that integral. So if you do it properly, if you choose a good u sub and you do the derivative and all the algebra that you need, if you do it, you should end up with an integral that looks like this. Nothing but u's in it, and that integral should be one that we can find the antiderivative of. Okay, would you agree that 1 over u is log u? And to keep WebAssign happy, I'll call it the log of the absolute value of u. And then I just turn the u into 7x squared plus x. Any questions about that? As a process, it's kind of cool, isn't it? It's pretty compact, at least right now. And it has a kind of shopping list of things that you do, and if you follow the shopping list, you should get everything covered. Right, this page is going to disappear. If there's any questions, this is your chance. Okay, let's up the ante a little bit. Let's try the integral of 6 cosine x over 7 plus 12 sine x all to the power of 3. I'm going to do my u sub down here. What would be our u sub in this question?
Seven x plus 12 sine x.
Okay, 7 plus 12 sine x. Aren't we working on the, if there's a bracket thing, that's the one you choose. So in this case here, we now differentiate with respect to x. That gets me nothing. Now, sines and cosines are the biggest bugaboo in my opinion, for people making very simple mistakes, because you're forever going one way and then we turn around and we go backwards, and it's very hard to keep track of it. What's the derivative of 12 sine x?
12 cosine x.
Correct. What's the antiderivative of 12 sine x?
Negative 12 cosine x.
Right, so you see what I'm getting about the plus minus issue, right? So as long as you're cool with that, then you shouldn't have too much trouble. Oops, so that crossover gives us this, great. And then when we isolate the dx, we get that. So that's pretty much guaranteed. Now I'm going to go up here. I'm going to have 6 cosine x's. This fella here is basically u to the power of 3. And the dx becomes a du over 12 cosine x's. With the du at the end. Right, that guy. Oh, I have 2 du's. No, it's the same guy. Now, cosines cancel. 12 and 6 gets you a half. So you're basically, that's who you end up with. Agreed? And that's a good sign, because that means that we've probably chosen the right u sub and that we've probably done the correct algebra to get to here. Now the power rule is add 1 to the power, divide by the new power, and then convert back to the x's. So this antiderivative is equal to that. Before today started, that is a non-starter. There is nothing you could do algebraically or trig identity or just being very good at manipulating various combinations of the two that would allow you to get an antiderivative of this. Can you just trust me that it ain't happening? Can you see that substitution rule was a godsend to a lot of different questions that had no other solution otherwise, right? We wouldn't be able to figure them out any other way. How about this fella? Oops. I need a u sub.
X cubed plus 1.
So now I can use that u sub by differentiating with respect to x, doing the crossover, and then isolating the dx. Now we come over here. I'll leave the x squared for just a little while. That guy becomes the square root of u, and the dx becomes this fella. The x squareds cancel, and I am now looking at that. Oh, okay. It is in terms of u, so that's a great sign. Is there anything I need to do here to be able to go further? Will I need to change how this looks in order to get an antiderivative? What do I change it into then?
e to the power of 1/2.
Are we comfortable about why that makes sense? Why a square root has to be called a half power? And we need to do that so that we can do the power rule. So the power rule is add 1 to the power. And divide by 3/2 is the same thing as multiplying by 2/3, which is why that is now 2/9. Add a C. What is our next step?
You substitute.
Okay. And the U is what? X cubed plus 1 to the 3/2 plus C. And that is the answer that WebAssign will probably accept. And even although it does accept it, style points that guy there, the one that's going to have the green box around it, is considered a better form than this. Can you see that a 3/2 is just a square root of something cubed, right? So that's the same thing as that, right? But this is considered a better form because isn't it in the same shape as the original question was written? And we have a kind of, it's not even an unwritten rule, I'm sure it's written down, so we have a written rule in math that says answer should look, whenever possible, like the question, right, in the form that the question was written. And secondly, do you know, if I haven't done any of them, I guess I should do it for this one. Can you imagine that you will get questions where you will be asked to find a definite integral, right? So you might say, well, how do I do it? You do exactly what you did here with one extra bit. When you get here, don't you then evaluate it at x equals 0 and x equals 1? Right, you don't have a plus C. That's really, isn't that the only difference? You find the value of the antiderivative at 1, you find the value of the antiderivative at 0, and then you subtract them, right? Now, if you plug 1 in here, you get 2, and 2 cubed is 8, so that's 2/9 the square root of 8. If you plug 0 in here, you get 1, and 1 cubed is 1, and the square root of 1 is 1, so you get that. Do you see that this form allowed you to get this answer in a way that looks nice? If I'd left it in this form, wouldn't I have an 8 to the power of 3/2, and I don't know what that is. And in fact, now that I've seen that, shouldn't I do style points on the square root of 8? Can you simplify the square root of 8?
2 square root 2.
So the final answer, as far as good math is concerned, would be that answer there.
I think it's the square root of 9.
Oh, did I screw up? What's the square root of 9?
It's because 2 cubed is 8 plus 1 is 9. Right?
Oh no, well, yeah, you're right, that is 9, but that's not what I did. I went 1 cubed plus 1 is 2, and 2 cubed is 8. So that's where my 8 came from. The way I said it made you think that I was getting 9.
Sorry.
But yeah, no, it's the way I said it. I should have been clearer. But cool about that question.
I want to clarify something
Yes.
real quick. So with the substitution rule, once we find out what we're going to use for our U, and then we are trying to find a the equation. So as on the second line with x squared square root of u.
Yeah.
So that where that square root of u is. So that's where you because we know u is x cubed plus 1.
So yeah, so this little guy here made that piece up.
Okay, so instead of putting x cubed plus 1 in there, we just use u so we can cancel out the u's. Is that what I'm getting at?
What we're getting to do here is that we're trying to convert this with all these x's by using this u sub and convert it into into things that only have u's, right? The only thing that they have is u's. And so an x cubed plus 1 will become a u. This x squared will eventually disappear, and so will this dx disappear. And they tend to disappear because of this line here. When you replace the dx with this, not only does the dx turn into a du, but see this little piece here, it very often kills off that guy there. And that combination ends up getting you this.
Okay.
Are we cool with that one?
Yep.
Professor,
Yes.
so you said, so like the past few problems, when we plugged back in dx, it cancels out with the front. So is that like a good like point to like make sure that you're doing it right, as if it cancels out?
So if I'm picking up rightly, you're saying is that when we plug in this bit for the dx, this bit over here gets cancelled out.
Right.
That's pretty much going to happen 9 times out of 10.
Okay.
And that's
Great,
a
thank
good
you.
sign that you're doing it right. One of the subtleties of the U sub is, this technique is, 90% of the time, exactly what's happening here will happen. But there are special, I'm not going to call them break the rules, but exceptions to the rule, where you may end up having an X left over, but we'll show you how to fix that. Or you may not pick the U sub that you think should work because it doesn't work, right? There's a different U sub, right? But those are like the special cases. And I don't want you to get the special cases to throw you away from being able to do 90% of the questions correctly. Because 90% of them, the U sub will be the one you think it is, and this guy will disappear the way it should, right? And 90% of the time that's going to happen, and we'll like 90% of the time. And then we'll worry about the special case situations where things don't kind of work the usual way, and we'll look at how you deal with that when it does turn up. But right now, we're not going to do any of them today, right? We'll keep away from them, and we'll look at them tomorrow, because they are a bit strange because they're not so clear cut when you get the sections. Let's see if I can find some special weird one. Right. Sometimes you just have to trust the process. Now you look at that, that is one weird looking integral. The cosine of pi over x cubed all over x to the 4. Oh, no, we'll call it the 90% rule, right? 90% of the time, the U subs you should pick is the right one. This is a 90% of the time. But we have a choice here. Isn't there a rule that says if it's an ugly cosine, you pick the ugly guy in the cosine? And then we have a different rule that says when it's a fraction, you pick the bottom, right? You can't pick both, right? You got to pick one or you got to pick the other. So there's a kind of little battle going on to which one is the right one to choose. Now you have a 50-50 chance of guessing the right one because you've never seen this before. But hopefully after you've seen a couple of these kind of where it might be one or it might be the other, you'll start beginning to realize that it's always this one and not that one. Go for it. Guess or tell me, which one do you think the U sub is going to work for this question? The ugly guy in the cosine or the bottom?
Bottom.
Pi over x cubed.
Okay. Don't go to Vegas. You'll lose all your money. You're a bad gambler. Choose the ugly guy inside the cosine. See if you get a question like this. Where you've got e to the ugly power or the x to the 4 in the bottom. So when you get this situation, choose the ugly power of e. See if you get guy inside square root or guy in the bottom. Choose the guy inside the square root. Do you see that the kind of the hierarchy here is that the guy in the bottom doesn't get picked very often. The ugly guy in the cosine gets picked first. The ugly power will get chosen first. The thing inside the square root will get chosen rather than the bottom of the fraction being chosen, right? So now that you've seen a few of them, the next time you have that choice, you're going to say, yep, I'm picking the ugly guy inside the sign, or I'm picking the ugly e to the power thing, or I'm picking the ugly thing inside the square root, right? Well, this fella here has to be converted to that guy. Why do I need to do that before I start my differentiation?
You need the power rule.
Yeah, need the power rule. Isn't it the same thing you do if you're trying to find antiderivatives? You got to have a power, right? Now, if you differentiate this guy, you multiply by the power. X to the what? What power do I put?
-2.
Negative 4.
Negative
When you
4.
differentiate,
sorry.
you subtract 1, don't you? So what do
Yeah.
you get?
-4.
-4. But I'm just doing that because that's a classic issue, right? Now, you want to do this, fella. The math is, the algebra, whatever you want to call it, is a bit messy. Would you agree that if I return it to this format, it's a little bit prettier, right? Now, my eventual goal here, isn't it, to have dx on its own? That's what I want, dx on its own, right? I've got this mess here. If you go and write down this, do you see that's what you get eventually? See, it's a little bit uglier to deal with, but that's the dx on its own. So it's like it's not technically cross multiplying, but doesn't it look like cross multiplying? Right? Divide both sides by -3 pi. Right, over here now, the cosine of this fella becomes the cosine of u. X to the 4, still there. The dx is now negative x to the 4 over 3 pi du. Can you see something really nice has happened? I will rewrite this fella like that. And that's exactly what you want to see. Don't you want to see an integral with nothing but numbers and u's in it? And this guy, we know how to get its antiderivative of, but be careful. Is it plus or negative 1 over 3 pi sine u?
Negative.
Negative.
Correct, because when you do an antiderivative of this, don't you get that? And then return back to the original. Is this cool? Do you like substitution as a method? Right. Works. Right. Okay, special case, special case. Okay. I'm not going to do this question. I just want to spend the last few minutes talking about who our U sub is again. Who's the U sub in this question?
Denominator.
Yep. Can you see that in this case, there isn't anything weird happening, so I don't need to worry about that. That works fine. Who's the U sub in this question?
One plus cosine 2.
Okay. Now, isn't this exactly the same math as that guy? Agreed? Oops. As that guy. Agreed? Dummy variables don't change the rules, right? So sometimes things won't be x's, right? Won't your U sub be something with t's in it, or w's, or p's, or whatever letter they happen to use here, right? But mathematically, don't we do exactly what we would have done anyway? It would still be that, right? How about this fella? Whoa, this one is sneaky. I didn't realize it until after I'd written it. This one is sneaky. I need a U sub.
Denominator.
The whole thing?
9 minus e to the x.
Only. Right. It has the denominator rule, but isn't there another rule, ugly guy inside brackets? And the ugly guy inside brackets works. If I made this 20, it would be even more important to choose that. So denominator is the least likely to be chosen if there's two choices, right? E the ugly guy or a denominator. Choose the ugly guy, right? Cosine of ugly thing over some denominator. Choose the thing inside the cosine. Something, I don't care what that is. Something to the power of 20. Pick the something. Don't pick the whole denominator. Right? Still part of that rule. Who'd you pick here?
Sine of x.
Yep. And we run out of time.